Antariki Vandanamu. Hope my voice is clear to you all. This is Nagarajan again. If so, please raise your hands just to check the voice and video. Or you can also, yes. I understand that when the school closes at 4, it may be taking some 2 or 3 minutes for the teachers to join this online webinar. So I just gave a few minutes time for them also to join. Good to see you all once again. Yesterday we did 4 or 5 I think 4 experiments. Evaraina practice chesara? Those 4 experiments in FET site or OLabs. Anybody tried? If you have tried, someone is saying voice is not audible. For others, if the voice is audible, can you please raise the hands? I don't see the hands raising. Ganesh, is the voice clear? Others, again, I'm not getting any reactions also. Can they tell whether the voice is clear or not? Can they give at least do a thumbs up or in the chat? Okay. Okay, good. I think a few people now replied it is fine. So maybe good. Today also, we will start seeing a few experiments. Let me start with this. I'm going to share my screen. Every day, we will be seeing different experiments. Okay. నేను my screen share చేస్తాను. Hope it is visible. Screen is visible, right? So now, today I'm going to take a few more simulations. If you take science, or say, let us say physics, you will always see motion and force, states, properties of matter, light, dhvani or sound, then electricity and magnetism, atomic physics combined with nuclear physics. Maybe in 11th and 12th, maybe some electronics may come. And this is pretty standard. Only the level will be different, but these topics or the chapters are pretty much same. Same way in chemistry also, you could see organic, inorganic, physical. At lower standards, it will be all one. But anywhere you will see elements, compounds, molecules, reactions, how to separate it from the ores, and then how to make use of that metal or an element. It's a pretty standard. Using these simulations, you don't have to feel like, oh, this has to be learned only by 12th student. Oh, this topic comes under, for example, today, first I'm going to take optics, lens. Again, in optics, just 1 second. In optics, you will always see lens and mirrors. One works with the concept of refraction, one works with the concept of reflection. And again, convex, concave, bi-convex, bi-concave. All these things are pretty standard. For example, if bi-convex lens concept comes, let us say 7th or 6th or 8th, whichever grade. When you teach with simulation, స్టూడెంట్స్ వేగంగా నేర్చుకుంటారు, right? So it is very easy. Same way for the teachers also, it is easy and faster to teach. Let us take bi-convex lens as the first experiment today. This is the lens. The lens will have a radius of curvature because it's part, if you look at this, this is an arc, part of the circle. So I can increase the radius of the circle. Okay, it is called radius of curvature because the lens one side is forming a part of the circle or a part of a globe, you can say. In 2D it will be circle, in 3D it will be globe. Now again, index of refractive index, whether the index of refraction is different, because depending upon the material of the lens, the refractive index will be changing, right? Now what I'm going to do is, let us start teaching again. For those who are coming for the first time to today's class, I'm again telling you, this session is not to teach you the subject. You already know the subject. As teachers, you already know the subject. This is to show and demonstrate how to use simulations for you to explain the concepts. That's all. The concept behind lens or concept behind mirrors, you already know. You have already been teaching this to kids using traditional methods, blackboard, chalk piece, or some animations or some pictures. You already do. Here we are going to learn only how to use these simulation tools. First concept, object is here, mirror image is here. Object will be on one side, image will be on the other side. First concept. Second concept, object is straight, image is inverted, ulta. This is another concept. Typically we draw all these things on the blackboard. Here there is no need for that, and it is not static picture. You are not showing a PPT. We are actually showing some simulation which is activity based. Now I am moving the object away from the lens. If the object moves away from the lens, image comes closer to the lens. I am moving it further away, image comes closer. Next concept, if the object is moving away from the lens, image gets smaller and smaller and smaller. Now, if the object comes closer to the lens, image will move away from the lens. Again, I come there, object comes closer, image goes away, image gets bigger. This is how typically in cinema movies, in theaters, 70 mm theaters, they are making sure that the image is formed at that, at even after 70 meters away from that projector. Now I am putting the object right on the focal point. If the object remains on the focal point, due to the refraction here, it is making a parallel ray. Parallel rays never meet, pretty much like the railroads. The two lines in the railroad, they do not meet. It's a parallel line. So image will not be formed. Now, if the object goes between focal point and lens, a virtual image is seen. Again, it is a Maya BIM. Virtual image is straight. Both object and virtual image on the same side. So in fact, to show this to the students, object further, object closer, object at the focal point, object between the focal point and lens, we may have to draw multiple pictures. Here, there is no need for that kind of multiple drawings. Another advantage, I have a scale too. This is called a virtual lab. Nijamaina lab ledu. This is Maya lab, virtual lab. This virtual lab also has a virtual scale. I measure distance between object and lens is this, which is U. Distance between lens and image is V. 1 by F is equal to 1 by U plus 1 by V. That is how we calculate focal length. Again, change the distance U. Again, measure. Again, calculate. 4-5 times, change the readings. Calculate focal length. Take the average. This is how we do in the lab. So the entire experiment can be done here. Okay. I stop sharing the screen now. I am coming back to video. So how do you like this? Maybe somebody would have come newly for today's session. How do you like this experiment? Can you give some reactions, or can you type it in the chat box, Q&A box? I'm waiting for your reactions. How do you like it? Is it good? You can give some reactions like thumbs up or claps or boring, something like that. Okay. I'm still waiting for any reactions from you all. Okay, just one reaction came. Okay. Actually, this is not good. Okay. I am expecting more reactions because you are all teachers, right? So I expect you to be more interactive than a one-way communication from me. I'm slightly disappointed. Okay. I expect you to come with more participation in this room. Good. Okay, now 2 or 3 hands are up. Because otherwise, imagine in your own class, nobody participates. You go and then take a training somewhere and you ask a question and nobody participates. How will you feel? Good. Now I could see hands are raising. That is good. But still, it can be much better. Because unless we engage ourselves, right, it will not be very interesting. Good. Now, this is the first thing. Again, what I'm going to show to you is every day we will see like this 4-5 experiments. Over a period of in a month, let us say we are going to have, I think based on the timetable, we have got Monday, Tuesday, Wednesday as teacher capacity building exercise. So imagine every day we see 3 or 5 activities, and based on that, within a week you will know 10 to 15 experiments. Over a month, you will come to know roughly about 60 experiments. Again, one of the fundamental reasons why we push this, only technology can give a better edge in terms of how to make things faster and efficient. So even as part of National Education Policy 2020 also, technology enablement is one important factor in education. Let me show you something. I think many of you would be already knowing this fact. What I'm going to do is, now I'm taking my phone. Okay. What I'm going to do is, I'm going to show you, this is a world of what technology. I am opening a Google product, Gemini. Whether we like it or not, technology will come and occupy our time. There is no escape. So we should, best way is embrace technology, welcome technology, but determine whether to use it for the right purpose or wrong purpose. Now I am opening Google Gemini Pro. I am going to give it instructions. Okay. Translate the following in Telugu. Okay.
మీరు ఏ వాక్యాలు అనువదించాలనుకుంటున్నారో చెప్పగలరా?
By using simulations, students can understand it very easily.
సిమ్యులేషన్స్ ఉపయోగించి విద్యార్థులు దీన్ని చాలా సులభంగా అర్థం చేసుకోవచ్చు. ఇంకేమైనా అనువాదం చేయాలా?
Translate only what I tell. Okay.
నేను చెప్పేది మాత్రమే అనువదించండి, సరేనా?
Yes.
మీరు చెప్పేది మాత్రమే అనువదిస్తాను.
In a month, you can learn 100 simulations and teach children in a better way.
ఒక నెలలో మీరు 100 సిమ్యులేషన్లను నేర్చుకోవచ్చు మరియు పిల్లలకు మంచి మార్గంలో బోధించవచ్చు.
Do you hear that? Are you able to hear that Telugu translation that I was doing? If so, can you please raise your hands? Yeah. Right. The thing is, this is the power of artificial intelligence. Okay. Today, I don't have to know every language in the world. This equipment is there. It is all very, very simple. And initially, if you noticed, it was telling something extra. I told translate only what I tell. The other day, I told with the higher tone, translate only what I tell. Then Google Gemini said, Shamijandi. Right? It said, forgive me, sir. To that extent, artificial intelligence is growing and technology is making a deep impact everywhere, including education. This is like I tell a sentence, after that it is translating. Now, another thing is also coming, live translation. That means I will speak in Tamil or Malayalam. I will ask it to translate in Telugu. As I speak, with just a gap of 5 seconds, it will start translating in live. That means without even knowing the other side or the other language, and it will do a perfect translation. It is working. So why did I show this? Because these are technology improvements that is coming like a tsunami. Machine learning and artificial intelligence are coming like tsunami. Best way is to adjust to that. You cannot oppose that. So how to adjust? But our responsibility is much more. Teacher responsibility is way high than anybody else in the society, because we are creating the next generation. We are creating the knowledge capital for the country. If the bank is saving money, protecting the money, we are protecting the knowledge. We are passing on the knowledge to the next generation. So as a teaching community, we have more responsibility. So we should ensure that we understand technology, we understand the goods and the bads of the technology, use it for the betterment in teaching. This is how we are interested in showing all these things to you. Let us do one more thing. Next thing that I want to show is, just 1 second. Since I just showed you the physics experiment, now let us show something like, let us take something from chemistry. Okay. I'm going back. I am talking in slow English so that anybody can understand. With minimal vocabulary, minimal knowledge in words, people can understand a lot. So that's why I'm talking in a very slow rate. Just wait. I'm going to show you molecules shapes. This comes in chemistry. Let us say real molecules. Okay. Now let us say carbon dioxide. So this is carbon, 2 oxygen is attached by this bond, right? What do you say this as? Single bond or double bond or covalent bond? How do you say that? Okay, good. Some people are typing in the chat box. Good. Again, our aim is not to teach chemistry. You already know that. But visually show carbon dioxide, the oxygen atoms are attached to these carbon atoms at this 180 degrees. Now let me change it to NH3. NH3 is ammonia. Nitrogen. You could see that the reason why they have put this real, they have given colors. Okay. If you see here, carbon dioxide, carbon is given in this color, oxygen is given in this color. Now if I go to SO2, sulfur is given in this color and oxygen is given in the same color, because you can relate it very easily. So in sulfur is here, these oxygen atoms are attached to this, right? Now let me take methane, CH4, carbon on 4 sides, the hydrogen atoms are attached. Let us take sulfur dioxide. Let us take water, H2O, right? So you could see different ways and angles at which the atoms are attached to the main atom. Here there are real models. Unfortunately, I don't have it here. I can show it from the lab. Black color balls, red color balls, yellow color balls, white color balls with some straw to attach. You can make people to actually attach these atoms to ensure that they understand the properties. Now let me show you model. Okay. In model, again, there is no color change. If you see here H2O or NH3, you don't see a models. Okay. You can do in a 3D, rotate and then see. See, I'm just moving my cursor, mouse. I could see top down of the atom, how these pairs are done and how this bonding is done. For example, I am taking carbon dioxide. I'm just changing it and then see how it looks, right? All these things are possible. Now let me show you one more thing. I just go back. Just 1 second. Just hold on. I'm going to molecules and shapes basics. Okay. Now I say remove all. This is a some atom. Okay. Let me show this. This is a single bond. Double. So to this, if I attach these things, how will they go and then pair with that? This is called a simulation. Whether there is an atom like this, I don't know. There may be an atom like, or is there like a molecule like this? I don't know. But I am just creating a model. If I have, I'm just showing, okay, with this one main atom, 1, 2, 3, three other elements are attached with the single bond. Another this thing is attached with a double bond, right? Is that triple? If I keep on clicking, at some point of time it will not allow me, because for a given main atom it will not allow more than X number of external atoms to get attached to it. You know how many electrons are the outer edge, and then how many things can bond with this, right? That you know. Now if I slowly remove one by one, how will it look? You can easily do. This is like you are creating your own molecule with a single bond or double bond, or how will it work? The moment I put all these things as this is like the children playing with that building blocks, right? There are a number of building blocks. You try to build it and then finally show. Same way we are building molecules. When we build the molecules, how will they bond? How will they get attached to the main element? We can show this. When you teach elements and molecules, you can show this, whether it is organic chemistry or inorganic chemistry. When the reactions do happen, you can show this. Okay. Now I am stopping this screen and then coming back. So now I am going to conduct a poll just to see. So far we have seen 2 simulations. I am conducting a poll. On your screen, a question will pop up. You can give your choice. Okay. Yes, okay, or no. You can vote. Okay. So there are about 182 people attending, and only 14 people have answered. Okay. I'll wait for maybe another 10 seconds or 20 seconds for you to vote and then come back. So this is to see again your opinion. I could see, right? Now I'm just only 31 people out of 181 people voted. 32 voted now. Now I'm just publishing the result. This is just, again, we'll be conducting more polls like this to know your opinion. I am publishing the result. It's saying actually out of 32, 24 said this is, do you like? Yes. 8 said okay, neutral. Okay. So I'm just refreshing that and coming back. So this is like how to know the engagement. And many people, instead of clicking there, right? There is one comment that came, KGPV Lepakshi students are very excited. I'm very happy. this is how it should do. And you can also allow, if there is a computer or a tablet or even the panel also, if you can allow the students to practice these things, because there is no expense needed for this, you can do. And another thing that came as this is very good, but the net connection is slow, sir, right? So it is affecting the flow again. So please talk to your infrastructure team. They will do that, because I am not in charge. But thanks for bringing it up. Yes, definitely internet is one important thing that that is needed for all these things. But I will also tell later how to download these things and then install in the, I'm not sure whether it will install on the panel, IFP panel, but on the PC, laptop or desktop, it will definitely install. Okay. So we have seen two now. I am going to take you to the third one. I'm going to show you how you can even teach maths using this. Okay. I'll start sharing my screen once again. Okay. Let me show you something. This may look very trivial, but even if you go to 4th or 5th or even to 6th standard students, if you start teaching something very simple stuff in mathematics, okay, let us say fractions, okay, build a fraction. If somebody, actually one of my professors told, if someone can master fractions, especially dealing with numbers, they can pretty much do anything in mathematics. So let us take the very simplest level, level 1. 1/3, right? Is this 1/3 or this is 1/3 or this 1/3? So suppose I say take this and then show, right? Is this 1/3? This is not 1/3. So how will I do that? And again, I'll put it here. I'll put it here. So there are 3. Now this is 1/3. Now you can drag, right? So now I'm just making it sure that I have built, this is 1/3. Okay. Now I just reverse it, correct? 1/2. How will I fill 1/2? Because we as a teacher, we will immediately know, but first time or the second class you are teaching fractions. So if I say this is 1 full, right? There are 2 plates. 2 is the whole. This 2 is the part. Typically fraction is, this is whole, this is part, or this is sum, this is part. So how many parts are there? So if I take 2, how will I build it? This is not the thing, that 1/2 is not this. So if I say I take 1/2, I take another half and then fill. So this is 2/2. Sorry, 1/2. Correct? So it is up to us to, suppose I do this, right? 2 pieces by 2 pieces. Now I say 3 pieces by 3 pieces, right? This is 1/2. If I move, so this is the way that you keep engaging the students. For example, I will show you one more thing. All it needs is a 5 minutes preparation. That's all. You don't have to, for example, now I took level 1. Let us take level build a fraction. Let us take level 2. Okay. Again, you could see here 3/4, 1/4, 1/3, slightly difficult ones. Again, you can go and then say level 3, right? 2 by 5, 1 by 6, visualizing one part out of 6 parts. How to build it, right? Now I have to say 1, 2, 3, 4. Okay. So only 4. If I say, I'm not able to fill further, right? If I put this one, again, it is not filling it fully. I don't have a piece like this. So it is up to us to demonstrate. If you fill something, it has to fill fully, and it is not filling. So this piece is not. So I need to remove certain parts. This portion, again, we need to teach the kids. So this is the way we have to build the, and again, if I take this one and if I take this one, now I am able to fill this entire circle, but they are not equal parts, correct? Whether you are filling it with equal parts or different parts, this we need to tell the kids how you can fill it, but different values. Again, whether it is, if I go back here, if I go to level 5, again you have got, if you look at, first we took circles, then there were triangles, now you are seeing rectangles. For the kids, recognizing the shape is also important. So while learning the fractions, people understand pentagon, people understand square, people understand rectangle, people understand circle. So double purpose is also served. So it is up to us to motivate the children using this kind of a tool. Okay. Now I stop here. Okay. Now let us, again, our capacity building doesn't stop only at simulations alone, because one thing from IIT Madras we strongly recommend, we very strongly recommend is inspire the kids with building reasoning mode, reasoning techniques. When I say reasoning, they have to keep thinking. As a teacher, we should make them think. Rather than making them study alone, make them thinking. That is also an integral part of coaching, integral part of teaching. And it doesn't happen in one day. I could see some sessions, somebody will say, okay, we will do analytical reasoning for 2 days. It doesn't happen. Learning a language or improving communication skills or improving analytical reasoning skills or personality traits. Okay, 2 hours of lecture doesn't happen like that. It happens over a period of time. Imagine the kids take you as a role model. They will exactly reflect you. Kids, children are the reflection of the parents and the teachers and the neighbors. They will start reflecting us like a mirror. So what we need to do is keep on inspiring them. So now I am posting a question. Okay, I am posting a question in chat box. Okay. Just wait. I am posting a question in the chat box. Q&A. Numbers 1, 3, 5, 7, 9, 11, 13, 15, 17, 19. What is the next number? Can you answer that? Who will answer that? So what is the next number? I posted a question. So I am giving to, imagine that I am giving to kids, right? Now, someone said 21, someone said 23. How can it be 23? Because it is, one logic is I am putting odd numbers, adding 2 by 2 by 2, 21. Now, actually this happened in reality. Our director went to a village asked this question. This is not in a private school in a town. This is a government school in a village. Our IIT Madras director went and asked this question. One kid answered in a very, very different way. Imagine. Sir, the next number is 31. What if I say next number is 31? Can anyone give the logic? One kid actually told this. This happened in real. Sir, the next number is 31. Can someone give the logic for that? Think. Typical way that we think is, oh, next number is 21 because you are adding 2 by 2. Everything is an odd number. So next number is 21. But that one intelligent kid stood up and told, sir, next number is 31. What is the logic? The reason is, someone has mentioned, I think Sistaji mentioned that the numbers you have seen are 1, 3, 5, 7, everything is an odd number. 13, 15, again, both the numbers are odd numbers. 17, 1 and 7 are odd number. 19, 1 and 9 are odd numbers. If you put the next number as 21, 2 is even, 1 is odd. So, whereas if you go 31, 3 is also odd, 1 is also odd. So the next number is 31 by this logic, sir. In fact, director appreciated that kid. That is the intelligence. That is called analytical reasoning. That's meaning they are thinking differently. Rather than thinking conventionally, it is called out of the box thinking, that you are thinking something very different. When so many people are thinking in one way, this person is thinking differently. Out of the box thinking. In your class also, there will be kids who can think beyond our comprehension. Identify. There are very good kids. Identify them. Nurture them. So as part of career thing, in part of capacity building, these are all the analytical. What we suggest is, one day, one small problem like this to solve. It should not take more than 3-4 minutes. You purposefully give one problem. Okay? Purposefully give one problem. A simple reasoning is to make them think. Again, you cannot give the thinking problem to a 11th standard kid and the same problem to a 8th standard kid. So you have to have different problems. There are many internet sites available. You can search for it, but make sure you give one problem to the kids every day. Let them solve for 5 minutes. Come out. Then you explain. This is the thing that makes the mind to start working. Exactly the way we do exercise for our physical body, we should make them think. Good. Now let me, so far we have seen only science and maths. Now I am sharing my screen once again. Let us go back to English. Yesterday I showed you the site word wall, right? We did something called jumbled sentences, correct? Now you can do one more thing. What happens is, if you try to go and then search from word wall, this is disabled because it will ask for subscription. You don't have to do for that. What you can do is, from Google itself, okay, word wall, word search examples. You can search from Google. Google will directly take you to that portion. It is a better search. Okay. Now, let me give you a simple example. I want to engage my students in finding out the words. search the words. It is, I am maximizing the screen. I am starting. In this, planet names are hidden. Find out where is Mars, or say Jupiter. Click here. So if I click here, Jupiter, it is here. So kids have to, if you go back in your primary stuff, FLN, Foundational Literacy and Numeracy. Again, I repeat, the kid may be in 8th standard or the kid may be in the 7th standard, but they may not have the necessary skills prescribed for 8th standard. They may have some confusion in the previous grade concepts. Reading and understanding is the foremost thing. Give some small exercise like this. It doesn't matter. It doesn't matter. I studied in Tamil medium up to 10th standard. I never talked in English at all. 11th and 12th, I studied in English medium, but I never talked. I never communicated in English. Only after coming to the college, I started communicating. It happens to a lot of kids. It is only a practice. English is not a subject. English is a language. It is up to us to give small exercises. Within 2 months, you will see magic in the kids. Now, where is Mars or where is Earth? Sun is here. Good. Neptune is here. Sometimes it may be in a cross also. It need not be in straight. Earth is here. It's also vertical now, right? So you can find out Uranus. Where is Uranus? Uranus is here. Basically, by reading the letters, they get practice, and it is making it interesting. Correct? So this is word search. So this is very simple. At the same time, for example, if I same game, I am clicking to Anagram. Okay, it's the same game. Instead of word search, look at how it happens. The letters are jumbled. Arrange it in the right order. So I have to say S, U, N. Next. What is this? People should see this is a jumbled letter. Yesterday we saw jumbled words in a sentence. Today we are seeing jumbled letters within a word. So M, suppose I take the next word as letter as R, it will say no. If I say Y, it will not allow me. Only when I take E, it will allow me. R, C, U, R, Y, Mercury. Okay. Next. Now, people need to know. Very simple thing. First letter is capital. So take as the take it as the first one. If I try to do the wrong thing, it will not allow me. It will be wrong. So it will stop me from doing wrong. It is the same word search. In one click, it came out. So this kind of a sites will be very nice. Okay. Now what I'm going to do is I'm going to I'm sending this in a, I stop my thing, right? I stop my screen sharing. In the Q&A, I passed the URL to you. In the Q&A box, I pass the URL to all. You can click, see it is working on your machine. Okay. Can you click on it and then see whether it is working? It's very simple. Just take a minute, do that, and tell me whether it is working on your mobile or tablet or laptop. Let us take 2 minutes. Go ahead. Please go ahead. I'm just pausing my recording because I'm giving you 2 minutes for you to practice on your hands-on on your laptop or tablet or mobile. I just passed on the URL. Try it and then tell me. Before I close the session, I am going to share another poll to you. Is that, do you find today's class interesting? You can answer that. Okay. Good. I'll wait for a minute, because typically, again, we can have anybody who wants to talk over the mic also. We can unmute, we can help you to unmute the mic and then talk. That is also possible. So a few interactions like this will help me understand your pulse as well. Good. Good. So what I will do is, I will right now, out of 30 people who voted so far, 31, I'm publishing the results, and then it says 26 people said yes, 6 people said okay, neutral. Okay. Now with that, I will stop today's session. We will keep continuing. Okay. Every day we will see minimum 4 or 3 to 4 experiments every day. So within a week, you will have the knowledge of 10 or 12 or 15 such simulations. You can start using it in your panel, in your tablets, to show to the students, so that it will be easy for you to teach, and kids also, it is easy for them to understand. So with that, I will stop today's session. And I once again thank you all. Thanks to all the teachers for attending this session. Though I am not able to see you all, I'm able to communicate to you all. Thanks a lot. Jai Hind.